guys, today we're going to be taking a look at functional group isomerism, which is a type of structural isomerism. So first let's take a look at the definition of the term functional group isomerism. So this is the type of isomerism that is exhibited by compounds that possess the same molecular formula. However, the functional groups or the homologous series is going to be different. So in the previous video, we talked about positional isomerism, in which the functional group is the same. In this case, the functional group is going to be different. So now let's look at the different examples that we're going to be talking about. So we're going to be discussing aldehydes and ketones, alcohols and ethers, carboxylic acids and esters, and alkenes and cycloalkanes. So we're going to be looking at different examples for each of these, and we're going to be discussing them in detail. Now we're going to be taking a look at the first example, which is aldehydes and ketones. So for aldehydes, this is a functional group. It's a carbonyl group bonded to a terminal hydrogen on one end and an R group on the other side. For ketones, on the other hand, the functional group is a carbonyl group with an R group on both sides of the carbonyl group. And all of this is discussed in detail in the video on aldehydes and ketones. So if you want to learn more about this, you can go check that out. So now let's take a look at our example, which is C3860. Now we can have an aldehyde for this. As you can see, this has a terminal hydrogen on this end, so it's an aldehyde. And you can also have a ketone with the same molecular formula. And this also has two R groups, like you can see over here on both ends. So even though the molecular formula is the same, which is C3860, the structural formulas are different, and the actual compound that you have is also different. Let's take a look at the next example, which is alcohols and ethers. So for alcohols, this is your functional group, which is the OH group. And for ethers, the functional group is going to be a hydrogen attached in the middle of two R groups. Now, the details of ethers are not in the AS level syllabus. However, you should know how to identify it. So now let's take a look at our example, the molecular formula of which is C4H10O. And in this case, you can have an alcohol. As you can see, this is an alcohol, which is butanol. And you have the OH functional group over here. And you can also have an ether, which has an oxygen in the middle of two R groups. So over here, similarly, even though the molecular formula is the same, the two compounds that you make are going to be completely different. So both of these are going to be classified as functional group isomers. Next, we're going to be taking a look at carboxylic acids and esters. So we're going to be taking a look at the functional group for both of them. So for carboxylic acids, the functional group is going to be C double bond O, OH. So this is the functional group for carboxylic acids. For esters, on the other hand, it's going to be C double bond O, O and an R group. So instead of the hydrogen, you're going to have an R group attached on one side. And this is how you differentiate a carboxylic acid and an ester. So now let's take a look at an example. So for this example, you can have an acid over here, which is going to be ethanoic acid, because you have two carbons. And you can also have an ester, which in this case is going to be methyl methanoate. And if you're confused about the naming of esters, there's a video on naming, so you can go check that out as well. Now we're going to take a look at alkenes and cycloalkanes, which also exhibit functional group isomerism. Now for this to happen, you need at least 3 carbons. So this is very important. You can have 3 or you can have more than 3, but having 3 carbons is necessary. Now the general formula for both alkenes and cycloalkanes is going to be CnH2n. So over here, if you take a look, you have propene, and the formula for propene is going to be C3H6. And you also have cyclopropane, and the formula for this is also C3H6. So similar to all the examples that we've done before for isomerism, even though the structures are different and the functional group is also different, the molecular formula ends up being the same. So this was functional group isomerism.